Today we're going to talk about matrices, a way of organizing and manipulating data that is widely used in computer science. For this reason, many majors require a matrix class to be taken in college.
Matrices didn't used to be a topic that was covered on the ACT, but in recent years we've started seeing problems involving basic matrix operations. Matrices are simple in concept, but the operations can start to get tedious and complicated, which is why we usually have computers do the operations for us, for anything other than very small matrices. Now, the ACT is purposely created so that it can be taken without a calculator, so any matrix problems that you see on this test are likely to be fairly basic in nature. TI calculators have great matrix features. That being said, operations on small matrices, like those you'll probably see on the ACT, are so simple that they can be done more quickly without the calculator. In this video, I'll cover the basics, including some vocabulary you need to know, and then we'll get into matrix addition and subtraction. Then in the next video, we'll go a little more in depth with calculator use and multiplication. A matrix is just a table of numbers arranged by rows and columns, and usually set inside of brackets. Rows go from left to right, columns go up and down. The order of a matrix is the row by, written with an X, the column. For example, a matrix with 2 rows and 3 columns has an order of 2 by 3, which is written 2x3. Each value in the matrix is called an element. We note a particular element using a lowercase a with a subscript of row, comma, column. Or you can remember that because it comes up with the word arc. What is the order of the matrix below? There are 3 rows and 1 column, so the order is 3 by 1. What would a 1 by 3 matrix look like? Here's an example. In this question, we're asked, what is A sub 3 comma 1 of the matrix? In other words, what is the element at the 3rd row and the 1st column? Start from the top row and count down to the 3rd row, then look at the 1st column. We see that the number located there is Y. If 2 matrices have the same order, they can be added. Adding matrices is very simple. The elements in the same position get added to each other. So A sub 1 comma 1 of the first matrix would get added to A sub 1 comma 1 of the second matrix. Watch what I mean in this example.
Some time just to settle down, won't you come around, 'cause I never can leave it alone. Tell me your stories, but don't leave out.
Wow, so easy!
Let's try one with variables. The concept doesn't change. We just combine like terms and come to an easy solution. Take a look at this example from a past ACT. Knowing that elements in the same position get added together, we can write a few equations to help us solve for the variables.
Won't you come around, 'cause I never can leave it alone.
I now have a system with 2 equations and 2 variables, so I should be able to solve it. I can already select the correct answer just by solving for x, since it's the only choice where the x value is 4. But to continue solving for y, I can substitute that value back into one of the equations.
Another easy concept with matrices is multiplying by a constant, or what we call a scalar. Think back to when you learned distributive property. Remember how everything inside of the parentheses got multiplied by the number on the outside? Well, this is the same concept with the matrix.
Everything inside the matrix gets multiplied by the constant, or the scalar, on the outside. Remember how when you multiply by a negative, the negative changes the sign of every term in the parentheses. Notice that the sign of each element changes. Positives become negatives, and negatives become positives. The exception is 0, which of course doesn't need to change because it is its own opposite.
Another numerical property that hopefully you learned in elementary school was that subtracting a positive is the same as adding a negative. So when we're subtracting matrices, think of it as multiplying the matrix by a negative and then adding it.
If I have 2 matrices, A and B, and I want to calculate A minus B, this is the same as A plus negative B. Subtracting matrix B is the same as adding negative B. This is how matrix subtraction is defined, as addition of a negative matrix. So if I want to find A minus B in this example, first I'm going to find negative B. Basically, I'm just changing the signs of each element inside of B. Now I'm going to add that to matrix A. Woohoo! Let's put it all together in this next example. First of all, I need to check that these matrices can indeed be added.
Matrices can only be added or subtracted if they have the same order.
Are they the same order? Yes, they both have 2 rows and 1 column. They're 2x1 matrices. Since they have the same order, we can proceed. First off, subtracting 3b is the same as adding negative 3b. So we want to solve 2a plus negative 3b. I need to do my scalar multiplication first. Take matrix A and multiply all the elements by 2. Then take matrix B and multiply the elements by negative 3. Now I'm ready to add the matrices together. In this example, the matrices were quite small, so it was easy to do all this by hand, and that's probably what you can expect on the ACT. But can I do that problem in a calculator? Yeah, absolutely. Watch how I enter the matrices on the TI-84 Plus. This would be a much more convenient method if you were given large or less straightforward matrices.
And that's wedding bells in a chapel. Been nibbling on the wrong apple. Living life emotions you never can manage. They picking me out of a raffle. Number 1 heartache coming from memories. Number 2 pencil style. We straight now, going opposite ways. These opposite days are making me think what to say now, and that's real. Running in circles, never leave me alone. Say I don't answer the messages or pick up my phone. Say we all need some time just to settle down. Won't you come around? 'Cause I never can leave it alone. Tell me your stories, but don't leave out the lies. 'Cause I know I got some problems and I'm open to mine. So we all need some time just to settle down. Won't you come?
The last thing we're going to cover in this video is the determinant. The determinant of a matrix is a number which tells us some things about the matrix that will become useful later. The determinant can be helpful for solving systems or finding the inverse of a matrix, things that we won't be covering in this video. But for now, let's look at how to find the determinant of a 2x2 matrix by hand. For a 2x2 matrix, ABCD, the determinant is AD minus BC. So we take the top left multiplied by the bottom right, and subtract the top right multiplied by the bottom left. Pretty simple concept once you've done a few of these practice problems. Let's look at another one that involves algebra. This is a perfect example of why you would want to know the determinant by hand. Because of the use of variables, we would not be able to enter this one into the calculator. We are told that that's equal to 0, so set it equal to 0 and then solve for x.
Running in circles.
A similar but more difficult example might end up giving the mathematician a quadratic or other polynomial. Again, write out the determinant using the formula. Be careful with negatives. From here, we would either factor or use the quadratic formula to find solutions for x.
This should give you some insight into the basics of matrices. Remember, practice makes permanent. It's important to make sure that you are practicing correctly. Get the basics down real well, become confident with them, and then move on to the more complicated.
The sound of the violins of the alarm clock, they waking me up when the harm stop. I'm dreaming we staying together, but honestly you kinda act like it's all games, and I'm tired of this.